So let's start with just kind of the very, very basics. What is this language like? It's interpreted. It's a scripting language, so there's no compile time. That means that there are certain compiler error messages that will not save you from silly mistakes, but we're going to talk about techniques that will help you avoid them anyway. It's object-oriented, and I know Java is also object-oriented, but this is different. Everything is really an object, and this is kind of the one pillar of the language you'll absorb. Once you understand this, that everything is an object, and the only way to do anything is to send messages to objects that call methods, it'll save you a lot of grief in trying to sort of decipher what might look like unfamiliar code. It is dynamically typed. What does that mean? Besides the fact that it means you can't tell the type of things with certainty until runtime, it means that although objects do have types, the variables that refer to them don't have types. So if you're coming from Java, this is going to seem weird. If you're coming from Python, you've probably already seen this. We'll do examples of all of this stuff. And probably most importantly for our purposes, it's highly dynamic. There's a lot of things you can do at runtime that in other languages you could only do at compile time. In fact, it's not too much of an exaggeration to say that in Ruby, there's no other time but runtime. Even things that look like class declarations are not really declarations. They're code that gets executed to create new things at runtime. So again, we'll see examples, but the fact that Ruby has this feature means that it's become pervasively used to make your code more concise and more elegant, and we'll do some hopefully informative examples of this today. Okay, so let's just do some basics, some naming conventions. Every language has naming conventions. If you're not familiar with the terms camel case and snake case, camel case has humps in it. So let's get the mouse over here. There we go. Upper camel case is when the first letter is uppercase. Snake case has little snakes, underscores between the words. These are real terms, folks. I'm not making them up. So conventionally, when you define a class, you use camel case. Method names and variable names typically use snake case. Notice that method names can optionally end in a interrogation mark, question mark. If it's by convention, if a method returns a Boolean or as a predicate, you end up with a question mark. You can optionally end it with a bang if it's a dangerous method, right? A method that does something destructive or that can't be undone. But those are conventions. You don't have to do that. Constants are in all capital letters, and they're scoped. That means that, like all other variables, they're visible only within the scope in which they're defined. There's also globals. They're in red because red is dangerous. Don't use globals. They're bad for you. But if you really need to use them, they begin with a $sign. They're usually all uppercase, and they really are truly global. You can see and modify them from absolutely everywhere. Big red flag. Symbols. Those of you who took CS61A Classic, where you did scheme, have seen the concept of a symbol before, but if you aren't familiar with the scheme language, this may be new to you. A symbol is really just an immutable string, a string whose value you can't change, and its value is itself. That's all it is. They begin with a colon. They don't have to be lowercase, but most commonly they are. It's not the same as a string in that you can convert back and forth. You can go from a symbol to a string, and you can go back, but they're not equal to each other. Now, why would you have two kinds of things? One argument is, well, you know, if you're going to have a lot of strings that have the same value, you could save some memory. But, you know, saving a byte here and there is ridiculous, right? The real reason that symbols are used in Rails is that they connote specialness. So when you see a method that takes a symbol as one of its arguments, typically what it's trying to tell you is, this looks like a string, but it's not an arbitrary string. It's one of a fixed set of possible values. Right? Now, again, as we'll see, idiomatically, some methods are written such that you can either pass a string or a symbol, whichever is more convenient for you. But in terms of using the language the way that Rubyists use it, a symbol usually means I'm not just a string, I am one of a fixed set of special strings. And it's not like I could have an arbitrary value. Okay, variables, arrays, hashes. There are no declarations. Okay, you have to assign a variable before you use it, otherwise you'll get an error. But when we talk about OOP in a moment, the instance and class variables of a class, those actually get default values of nil until they're assigned. So it's OK to dereference those. So it might seem strange, unless you've come from a language like Python, to see something like x equals 3, and then a few lines later, x equals a string. But that's perfectly fine, because again, objects like 3 and foo have types, but the variables that refer to them don't have types. Right? The only thing that has a type dereference is when you try to use the variable, the thing that it references, that's the type that matters. You'll never see something like this, because there are no declarations. Arrays. Standard linear arrays like in every other language. But again, what might seem new to you is arrays don't have to have elements that are all of the same type. So you don't talk about an array of ints or an array of strings. It's just plain old an array. Right? You can dereference elements of the array with a numeric index. That should look familiar. You can ask it what its length is. This should all be familiar from other languages. And similarly, hashes. There are a few different notations, but this is probably the most commonly used one involving braces. Just like an array, the keys and values of hashes don't all have to be of the same type. In practice, they often are, but so that I'm telling you the rules honestly, here is a hash whose first key, well, I shouldn't say first key, hashes aren't ordered, but that has a key, which is the string A, the corresponding value 1, the symbol B, which is not the same as the string B, and the value of that key is an array. So in fact, the array and hash elements can be anything at all, including other arrays or other hashes. They don't all have to be of the same type. If you've used Python and Perl hashes, you kind of think of them as the Swiss Army chainsaw for building up data structures, not too different in Ruby. OK, we're almost through with nuts and bolts stuff. Methods. Everything is basically passed by reference. So here's a very simple method definition. Foo of x and y, whoops, sorry about that. That just returns an array of x and y plus 1. How could you call this method? Well, down here, you could call it with a comma b equals foo of x and y. Right? You can assign to individual elements as well as to an array. I could also, in my definition of the method, supply a default value for some of the arguments. And that means that if those arguments aren't present in the call, they'll be assigned the default value. So if I just call this with foo of x, as long as I gave a default value for y, that's a legal call. For obvious reasons, you couldn't, for example, specify a default value for x, but then make y a required parameter, because there'd be no good way to parse that. All right, so that's also legal. And lastly, although typically statements are separated by new lines, they can be separated by semicolons. It's less usual, but sometimes if statements are really short and like an entire method will fit on a line, you'll sometimes see that. OK, and last but not least, I think, some basic constructs. Statements end with semicolons or new lines, but if the parsing is unambiguous, they can actually span a line. So what does that mean? Looking at the statement on the left, raise is a way to raise an exception. This is all in the book, by the way. So raise this exception unless the ship is stable. Breaking a line after unless is legal, because in terms of parsing, unless can't be the last thing in the statement. It's got to be followed by some condition. But on the other hand, on the right-hand side, breaking the line after raise boom is going to be a problem, because raise boom all by itself is a legal statement. So the parser will actually stop there, and then the parser will complain that you've got an unless without a corresponding thing to do. Okay? So again, when in doubt, do the defensive thing. But because you're going to be looking at a lot of Ruby code, I wanted to show you some examples of different ways that you'll see things done. All of the basic comparisons that you would expect, including equal twiddle and bang twiddle, which are for regular expressions, which we'll look at in a moment. Boolean values. True, false, and nil are constants. False and nil are the things that in a conditional statement evaluate to false. Everything else in a conditional statement evaluates to true. So beware if you're used to Python or Perl, where things like the empty array or the empty string will evaluate to false. Not so in Ruby. Okay? If it's false or nil, that's false. Everything else, absolutely everything else, is true. And again, as in most other languages, the usual control flow, you've got if with else, you've got while statements, you've got various kinds of loops, but I don't really want you to think too much about the loops, because during the lecture today, we're going to see that, in fact, loops are just a special case of a different kind of Ruby construct called an iterator, which is pervasive. OK, strings and regular expressions. Just last week, I discovered a great new site called Rubular. Try it for all of your regular expression needs. If you have used regexes in other languages, Rubies are pretty comparable. Haha, get that? Never mind. Thank you. Wake up. OK. Strings and regular expressions. Various ways to express a string. Basically, if a string has double quotes around it, you can embed expressions into it with this pound brace notation. Strings with single quotes have nothing done to them. And what is this %capital Q and %lowercase q? These are just ways to represent strings that have special characters in them. So one way to have a string with double quotes in it is to use %cap q or %lowercase q to quote it. How do you match strings against a regular expression? One syntax is the one that Ruby has borrowed from Perl, Python, and other languages. I can take a string and use the equal twiddle operator to compare it to a regular expression. Since you've all been keeping up with the reading, you know that this regular expression is going to match an email address, with the first part being the part before the @ sign and the part after the @ sign, and that it's going to capture both of these groups. We'll talk about accessing the capture in just a moment. Interestingly, you can also reverse the sense of the comparison, and in a moment we'll talk about why this works. But I could also take a regular expression and equal twiddle compare it against a string. In either case, if the match fails, then the value of the expression as a whole is false. If the match succeeds, you'll get a non-false value. Depending on which form you use, you get different non-false values. But you'll be able to capture all of the expression groups with $1 through however many parens there were. So in this example, when I'm matching this regex against fox@berkeley.edu, this first group of parens is capturing everything before the @ so $1 will be the string fox that match that. And the second group of parens will be captured by $2. That's everything after the @ sign, which is actually Berkeley just Berkeley, because the .edu anchored to the end of the string is outside the match. One of the things that I've always kind of hated about programming classes is we expect you to write code in a new language without letting you read code in that language. You would never take a writing class in literature and have them say, write a great essay, but don't ever have read, the great essays of other authors. So once in a while, I'm going to show you an example of code that I don't necessarily expect you to fully understand, but it's because I want to acclimatize you to what some of these things look like in real life. So with that in mind, let's take a look at an example of a real use of regular expressions this way. Click. Good. I was hoping that would work. OK. By the way, I love pastebin. OK, so here's an example real-life use of a regex. Let me see if I can make that a little bit bigger. This is actually a snippet of code from the auto grader that's going to be used to grade your all's homework, in case you're interested. So what's going on here is we actually run RSpec, which is a testing tool in a controlled environment. And from its output, we look for a message that says how many examples, how many test cases were run, how many failures there were, and optionally, how many were pending. And if the match succeeds, then we record how many total failed and passing examples you had. And if the match fails, then we throw up our hands in despair. And hopefully that doesn't happen too often. But again, the goal of this is not to have you parse the entire piece of code that's on the screen. It's to give you a sense of what code looks like. So as you see more examples, you'll become more comfortable with it. All right. So I think with that in mind, we can do our first mental calisthenics.